So hey, we will solve the max grid construction problem here. So what we have here is we have been given n and we will have to construct the max grid of n cross n size. So if you have not tried to observe a pattern, there is a pattern here. So we will just try to observe the pattern by constructing a grid of n equal to 8. So we'll have this as an example. So first let's construct the first row that you can easily see this is 0, 1, 2, 3, 4. So we have 0, 1, 2, 3, 4, 5, 6, 7. And then as you can observe, this is a symmetric matrix. So we can just copy this 0, 1, 2, 3, 4, 5, 6, 7. And then now if you observe for this value, this element's value, we can just have it 0 because we don't have 0 above and on the left. Then we can have here, we don't have, we have 2, we have 0 and 1. So we can just have 3. And then we can just copy this symmetrically. And we will always have 0 on the diagonals. So let's just try to go ahead with this. We have 3. We have 0, 1, 0, 3, so we can have 2. And this is 4. We have 0, 0, 6, so we can have 5. We don't have 4 here, so we can have 4. We don't have 5, so we have 7. 0, 1, 2, 3, 4, 5, 6. Yes, we will have 7. And we will have 6. So similarly, we can just construct this 3. Sorry, not this. 5, 4, 6, 7, 7, 6. So already, if you are able to see, we have the blocks. Like you just need to observe the blocks of 2 cross 2. This will show you the pattern. So if we have this blocks of 2 cross 2, then we can just check this. Like what we have here, we don't have one, so we can have one. Do we have one here? No, we cannot because we have the symmetric pattern. So we have these 2 cross 2 blocks occurring here. So we have these block here, and we will have this block here. Then we have this block here. Sorry, not this. We have this block here, and then similarly we have this block here. So we can just copy the alternate diagonal halves are symmetrical because of symmetry. But this occurs every time. So just check this. Also, the main diagonal halves are symmetric. You'll just see this in a minute. So if we just go on constructing this, we will have this, like we will have today it is 6, we'll have to put here 7, then we'll have to put here 7, and then we'll have to put here 6, and then we'll have 4, 5, and then we'll have like 4. So I'll just construct this 4 cross 4 matrix, and then we can just copy this here. This was because alternate diagonal halves are symmetric, and then we can just what you can see is we'll have the same these elements going here. So we can always copy these to these, and then we'll have these the same. But what I want you to observe now is just think in 2 cross 2s. So I will just divide this and give this a space, a bit of space. So if we just see this now, what we have done is this is a 4 cross 4 grid. So this is the exact copy of this matrix plus 4. So we'll just go down and increment each element by 4. And we will similarly just go right and increment each element by 4. If you are unable to see this, just wait and check this out. We have 7, and this is 3 plus 4 is 7. Similarly, we will have this also here. But the thing is, this remains plus 0. this half remains, you can say like this half remains equal with the with this half, this upper half matrix. This matrix of upper half is same as this matrix of upper half. Okay, not this, sorry, this. So we will have to copy these two and these two. So we just need to check for the two. But what if we go one step beyond? What if we go like what is happening in 2 cross 2 level? Is it the same way? Yes, it is. So we can just see this is plus 2, this is plus 2, this is plus 2. So each element of the 2 cross 2 matrix is also same. This matrix is copied. So we will just have to copy these two matrices. At each element, this is 0 plus 0 plus 2 is 2. 1 plus 2 is 3. 1 plus 2 is 3. 0 plus 2 is 2. And similarly, we will have this for 1 plus 1 as well. This is plus 1 and this is the pattern that I was talking about. So 0 plus 1 is 1, 1 and 0. This is plus 1. So this is the pattern. So this is in every point of this matrix. So we will just have to go to the powers of 2 because after plus 4, there will be plus 8 waiting there. We follow the what pattern and we will just copy plus 8 from these 8 rows above it. So let me just code it through using this word. So just pattern observation does this. So we can just code this now. So we have just int n and, and we'll have a iterable matrix. We have this. Let's give it people this. Let's give it and we have it. So we just have the next one here. This will be initialize. So we'll have a function that will build this next grid by observing this pattern. So let's check what I built in the function. Let us just like this function will be called for each and every value. So 0.50 j0 and we will have this build function I comma j. This will be taken as void build. I will not call recursion. I will just build it by observing the powers of 2. So this will be R, this will be C. So we have R and C. We need the powers of 2. So let us just write the powers of 2 that we need after n powers of 2. So we'll have this. You can just directly assign right to build. If we have only 100. So we'll have, let's start from 0 so that we can have a base value. 54, 8, 16, 32, 64, 132. So these are all done. And what we'll have next is we will have I and J, and these will have the value which we have increment from the value which we can refer to in the matrix that has already been filled. Okay, so we will just have this. So if we go like while powers of 2 I is less than equal to R, I plus plus, and similarly we can do this for say where R will transform to C and I will transform to J, and we can just initialize J to 0 as well. This will work and I will do as well. So this works. Now we have the lowest power of the highest power of 2 that is beneath R and C. So we just know from where we will have to copy this. So for example, if we are in this element, then we have the lowest power of 2 beneath this element is 1. Okay. And beneath in the column it is 1. In the row it is 4. So we can just go to I, sorry, actually R minus 4 r minus 4 and copy that. So let me just copy this for example. We can just so if we have this, we can just for this element, we will have this. So for this element, we can have this is 2. So we can just go here. We just observe the highest value of 2 of 2's power. That is lower than this element's indices from I comma j. And then we will just increment the reference value with that power of 2. So let me just show it to you. So we'll just see if so we'll just need to decrement this once so that we can just stay in the limits. So if but as you know, the diagonal is copied, so we'll have to copy this from here, right? From the first values, we'll have to copy this thing. The 0, 1, 2, 3 will still be copied here. So we'll need to use that. So we can just check if both the powers of 2 are equal, which are then at that I and j. So if power 2 of I equal to power 2 of j, we will have to assign the value of next grid of I of r comma c, sorry, is equal to the next grid of I, so not this, we can have it r minus power of 2 I c and power of 2 j. So we'll just have to copy it on diagonal half. And then we can have if power 2 of I is greater than power of 2 of j. So we have, and we can just return from here, we don't need to do anything else. So we will have this, and we can just go, if we are having power of 2 of I is greater than power of 2 of j, then we are in this, in the vertical scenario. So we'll have to go vertically up and find the element. So next grid of R from C will be equal to next grid of R minus power 2 of I C. Similarly, we can do the same for J. And then it will become this big directly. And this will just be minus power 2 of J. This works. And this will work. So we just need to print the grid now. So we will have to just print next grid of I because we have put I and J. So we just print this now inside this. And this end line here. To print the grid. So it's just like it is what of if this works, it is done. If this don't works, it is check. Why? Because we have not incremented the value. Increment the house. So you'll have to increment this with power to right and power to change. So just like then it should be good to go. Yes, we are good to go. So if you just go to 5, okay, so this is 5, so yes, 5. And this should be done. Yeah, this works. So let's just go ahead and put it. If we just go next, let's see if we can select this. Does this work? Does this work? Yes, it works. So thank you.